Hi, my name is Vineet, and today we're going to look at adding signal processing and analysis capabilities to a data acquisition application. If we look at LabVIEW here, I've already got my basic measurement task done. I can hit run and I'm already starting to take measurements looking at my sine wave. Well, it's very common to do signal processing and analysis in data acquisition applications. And the LabVIEW Express palette actually has a number of capabilities to address some of the most common types of signal processing. I can make some space in my while loop here and right click and go to the Signal Analysis Express palette. And here you can see the number of different options I have available to me using this Express technology. In this particular example, we're going to add filtering and frequency domain analysis to my data acquisition application. So I'm going to drop down the Spectral Measurements Express VI. And in this Express VI, I can wire a time domain signal and generate the corresponding power spectrum and see what types of frequencies I have within my signal. So I'm going to choose power spectrum here and hit OK. And now it's just a question of wiring the data that's coming out of my DAC assistant directly to the input terminal of the spectral measurements VI. I can right click on the output of the power spectrum and choose to create a graph indicator. Once I do that, you can see on the front panel I've got a graph that's been generated, and I can move my stop button down to the bottom here and make some space and actually drop down my frequency domain data directly below my time domain data. Next I can hit run, and right away I can start to see my power spectrum. Let's go ahead and make this line a little bit thicker so it's easier to see. And now as I reach over to my function generator that's generating the sine wave, I can speed up the frequency, and you can start to see the frequency being measured on the graph. I can adjust the graph as well. I can stop the auto scaling on the Y and X axis and zoom into a particular section. And so let's say I'm only interested in frequencies up to 1,000 hertz. Well, I can zoom in on that. Now I have a little better clarity on my data points. And now you can see as I speed up my frequency or slow it back down, I have the corresponding frequency domain data. Now we'd also like to add some filtering to the application. And so I can right click on the block diagram, go back to the signal analysis palette, and then choose the filter Express VI. This Express VI gives you a number of different options for filtering. In this case, we're just going to add a pretty common low pass type filter. I'm going to set the cutoff frequency at 500 hertz, and we can just leave the topology as a Butterworth filter, a pretty common type of filter. And now I can wire my output data to that input terminal on the filter Express VI. Next, I'm going to break the wires that are going to the spectral measurements VI, because what I really want to now do is send the filtered signal over to the Express VI to measure the frequency domain data as well as the time domain graph. So I can delete that and rewire the data there. And now when I hit run, I can see the same data that I was looking at before. And now as I increase my frequency, you can see as I get closer and closer to that cutoff that we had set at 500 hertz, suddenly my signals above 500 hertz become attenuated down. So I've effectively implemented a low-pass filter along with frequency domain analysis in my data acquisition application with LabVIEW and an NI data acquisition device.